Question 11. There are two tanks on a property, Tank A and Tank B. Initially, Tank A holds 1,000 litres of water and Tank B is empty. Part A. Tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water in Tank A is modelled by V equals 1,000 minus 20T, where V is the volume in litres and T is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as Tank A. V equals 1000 minus 20t is a linear model and its graph will be a straight line. To draw a straight line, we need a minimum of 2 points to locate it. So it was easy enough to find the y-intercept and the x-intercept by letting t equal 0 to find the y-intercept and v equals 1000, and to find the x-intercept I let t equal 50 and v equals 0. And so just joining the 2 points there, we have the line that represents the graph for Tank A. Part B. Tank B remains empty until t equals 15 when water is added to it at a constant rate of 30 litres per minute. By drawing a line on the grid on the previous page, or otherwise, find the value of t when the two tanks contain the same volume of water. An algebraic approach will be used to answer Part B. First, we need to determine the equation that models the amount of water in Tank B, and it's a linear model as well. We know that the gradient is 30, since that comes from the question, water is being added at a constant rate of 30 litres per minute, and we know that at time equals 15 minutes at that instant, there's no water in Tank B, and it's from that point onwards that water is being added at the rate of 30 litres per minute. So we need to determine what the y-intercept will be. So the model is y equals 30t plus c, and we need to determine the plus c. And we know that at time t equals 15, at that instant, there's no water in Tank B. So 0 equals 30 multiplied by 15 plus c. 30 multiplied by 15 is 450. Therefore, c, the y-intercept, is negative 450. Therefore, the equation that models Tank B is y equals 30t minus 450. Now we solve the equations y equals v simultaneously. So we want to find out at what time the two tanks will have an equal amount of water. So y is equal to 30t minus 450, and we equate that with the equation for v, which is 1000 minus 20t, so that's the amount of water in Tank A at some point in time t. And collecting like terms and solving for t, we have 50t is equal to 1450, and dividing both sides by 50, we have t equals 29. So therefore, the tanks will contain the same volume of water right after the 29-minute mark. Part C. Using the graphs drawn, or otherwise, find the value of t, where t is greater than 0, when the total volume of water in the two tanks is 1000 litres. Since we've already determined the equation that models the amount of water in Tank B, we can use an algebraic approach for Part C. We're going to solve the equation y plus v equals 1000 for t, where y represents the amount of water in Tank B, and v represents the amount of water in Tank A at some point in time t. Now y is equal to 30t minus 450, and v is equal to 1000 minus 20t. So combining the like terms, and just rearranging the equation, we have 10t is equal to 450, dividing both sides by 10, we have t equals 45.